In this video, I'm going to talk about scientific notation. Scientific notation is just a more convenient way of communicating really small or really large numbers. Here's an example. 1.432 times 10 to the third. So what are the characteristics that we're looking for in scientific notation? The first is that we only have one number or one digit to the left of the decimal point. In this example, we have a 1. It needs to be something between 1 and 9, but not 0. So that is a key characteristic. Next, we're looking for a multiplication symbol. And finally, we have a 10 times 10 to some exponent. And that exponent is either going to be positive or negative. If the exponent's positive, it means we're talking about a large number. If it's negative, we're talking about a small number. So let's talk about the rules for converting big or small numbers to scientific notation. So the first thing we want to focus on is getting that exponent. What is the value of that exponent? And what we're going to do is count the number of decimal places to get the decimal to the right of the first number that's not a 0. We'll go through an example in a moment. For big numbers, I'm talking about big numbers that are 10 or larger, the exponent will be positive. And for small numbers that are less than 1, the exponent will be negative. So here's an example of a large number. Now let me show you this process of counting. First of all, when there is no decimal place shown, we can assume that it's right there after all of the numbers. And now we're just going to count the number of decimal places to get our decimal right here so that we will have a 1 to the left of it. 1, 2, 3, 4, 5, 6. We have to move the decimal point 6 places. So we know that our answer in scientific notation is going to contain a 10 to the 6th. Is that 6 a negative or a positive is another question. Because we are dealing with a big number, it's going to be positive. So we can kind of leave that alone. And then we simply write what's left of our number. We're going to ignore all of these zeros to the right-hand side, and we're just going to write 1.5 times 10 to the 6th, because we moved the decimal point right there, 1.5. Again, we can ignore all of those zeros. They don't really help us out. Okay, let's take a look at a small number. So in this case, we need to move our decimal point right there between the 6 and the 4. And notice we're going the other way. That's because it's a small number. 1, 2, 3 decimal places. So our answer is going to have 10 to the third, but because it's a small number, it's 10 to the negative third. And then let's fill in what our number is. We have a 6 to the left of the decimal. Remember, we will always have one digit there. And then 0.4. 6.4 times 10 to the third would be the answer to that problem. All right, sometimes you'll have to convert from scientific notation to what we call standard form. Standard form just means kind of a regular number. The exponent tells you how many places to move the decimal. Positive exponent means move right. Moving right will give us a big number. A negative exponent means move left. Moving the decimal point to the left will get us a small number. This is the hardest part of the scientific notation, is keeping the direction straight, whether the exponent should be negative or positive. With a little bit of practice, this will come pretty easily. So in this case, we see that we have 4.43 times 10 to the 4th. The fact that this is a positive 4 should tell us big number. we're going to end up with a big number. That means we should move to the right. So we could rewrite this. And we're going to move to the right 4 places. We're going to start here. We're going to go 1, 2, 3, 4. Now notice we moved way out here and we've kind of jumped over numbers that don't exist. What we should do is put zeros in those places. So that's the number that we're talking about. We should also put a comma in it. There should be a comma after the 3 digits. So that would be 44,300. Positive exponent, big number. It all makes sense. Let's clear that off and we'll look at one more example here. 3.21 times 10 to the minus 2. Right away, we should take note of this and say, oh, minus 2, this is a small number. I better end up with a small number. So let's rewrite what we have here. Actually, I'm going to do it with the number that's already there. We're going to start here, and we're going to move our decimal 1, 2 places to the left. This is going to be our new decimal place, and we should add a 0 here because we're missing a digit. So now we could rewrite that. We should always put a 0 before the decimal point 2 when we're writing in standard form. 0.0321. That's our answer. All right, let me clear that off. We'll go to our next screen and we'll do some practice. Just a little bit of practice before you get to practice on your own. Okay, here we have a big number. That means our decimal point is here. Let's count the number of places. 1, 2, 3, 4, 5. Our decimal is going to be between the 1 and the 2. We can drop off all the zeros, so it's 1.25 times 10 to the, what did we count again? 1, 2, 3, 4, 5 to 10 to the 5th. You want to make sure that you count that correctly. Small number. Right away, we should see that as small number and be thinking we're going to have a negative exponent. Let's count our decimal points. Our decimal point moves to get between the 9 and the 4. 1, 2. So 9.4 times 10 to the negative 2. Small number, negative exponent. We have 1 digit to the left of the decimal. That's another thing to check for here. 573. Our missing decimal point is right there. We go 1, 2 places. It's a big number, so our exponent is going to be positive. 5.73 times 10 to the second. Sometimes these problems will be in the form of words. Here's an example. The smallest grain of sand is about 0.0025 inches. What would this be in scientific notation? Okay, we have a small number. We should be thinking we're going to have a negative exponent. 1, 2, 3 places the decimal needs to move to get between the 2 and the 5. So our answer is going to be 2.5 times 10. We moved 3 places to the negative 3. Keeping in mind the sign of your exponent is really important. Okay, let's move on to some problems where we have to go the other way, where we're given scientific notation and we're asked for standard form. So this positive exponent tells me that this is a big number. We are going to move 1, 2, 3 places to the right. We'll add a 0 here. Let's rewrite that. 1, 2, 3, 0. Our decimal point would be at the very end there, and we should add a comma there. So that's 1,230. Next problem, 9.9 times 10 to the negative 2. Negative 2 tells us that this is a small number. our decimal point is going to move to the left for small numbers. And it's going to move to the left 2 places. 1, 2. We add a 0 here, and our new decimal is going to go right there. And our answer would be 0.099. And we should add a 0 in front there. 0.099. Let me clear those off so we can focus on these last problems. 9.9567 times 10 to the second. We have a positive exponent. This is going to be a large number. 2 places to the right. We get 995.67 based on moving 2 places to the right. Here's another example of a problem that involves, sort of a word problem. The distance across the United States is about 1.48 times 10 to the 7th feet. How would this number be written in standard notation? Now, this is an example where it would be helpful to rewrite this number. So I'm just going to write little decimal point there so that we can keep track of where we start. And we need to move 7 places to the right. This is going to be a really big number. 1, 2, 3, 4, 5, 6, 7. Here's going to be our final decimal place, and we need to fill these all in with zeros. And when we're done here and we add some commas, this should start to be a familiar form of a number to us. We put a comma after the first 3 digits, we put a comma there, and the number that we have is 14,800,000 feet across the United States. So just an example where you might be asked, it's really the same kind of math that you're doing up here, but you're doing it in the form of a word problem. All right, that's it for scientific notation. It's time for you to do some practice on your own.